Good morning, all of you. Today we'll find out relationship between zeros and coefficients of a polynomial. We are starting with a question that we have to find zeros of a given polynomial px is equal to 2x square minus 8x plus 6. All of you know factorization of a quadratic polynomial. See here, for finding factors of quadratic polynomial, this is a quadratic polynomial, px is given by 2x square minus 8x plus 6. This is a quadratic polynomial and we'll find out its factor by splitting middle term. Here middle term is minus 8x and this minus 8x, this we have to split. See here, according to this polynomial, the coefficient of x square is 2 and this we will say it as a is equal to 2. Now coefficient of x, it is minus 8. So b is equal to minus 8. And 6, this is a constant term without any variable. So constant term is 6. See, whenever we have to split the middle term, what we have to do is we will find out two factors in such a way that multiplication on multiplying these two factors or product of these two factor will be a into c. Here our a is 2 and c is 6. So we have to find out two factors in such a way so that their product is 6 2s are 12. And now see here, and there's some more difference. It should be b. On subtracting or on adding them, we should get b, that is minus 8. So the two factors are, see here, minus 6x and minus 2x. Minus 6 multiplied by minus 2, we will get 12 and the sign will be plus. And see here, minus 6 minus 2. On adding them, we will get minus 8. So on splitting middle term, minus 8x can be written as minus 6x minus 2x. First term 2x square, it will remain as such. This 6, it will also remain as such. Now we'll see 2x square and minus 6x. We can take 2x as common. And when we have taken here 2x as common, here only one power of x remains. Now 2x we have already taken out. So here only 3 remains along with the negative sign. See here 2 3s are 6 and here it is x. So this x will go here. Now in minus 2x and plus 6, we can take out as a common minus 2. Minus 2 we have taken out as common. So here it will remain x. And as minus 2 we have taken here common. So inside the bracket there will be minus. Minus into minus. Here it is plus. 2 3s are 6 plus 6. Now see here. In here x minus 3 is present here also and here also. You can take it out as common. Say you have taken it out as common x minus 3. So here it remains 2x. 2x we have written here. Minus sign. And again we have taken this x minus 3 as common. So what remains is only 2. It can be written as 2x minus 2 and within bracket x minus 3 here. Now see here 2x minus 2. From this we can take 2 as a common and then inside the bracket x minus 1 will remain. Now we have factorized this given equation and we are getting 2x minus 1 and x minus 3 as its factor. Now when we have to find out 0, what we have to do is we'll equate all the factors to 0. Now look here one thing. Here one factor is 2. All of you know that 2 can't be equal to 0. So out of these two, either one will be 0 or both will be 0. So case first, x minus 1, we have taken it as 0 in order to find out 0. And we have to find out value of x. This one we will take it to the next side, then it is positive 1. The value of x is equal to 1 and this is only first 0 of the given polynomial. We will denote it by alpha. Zeros are generally denoted by alpha and beta. So first 0 of the given quadratic polynomial is 1 and we will denote it by alpha. Now for finding out second polynomial, this x minus 3 we will equate it equal to 0. Now see here, x minus 3 we have equated equal to 0. Now we'll find out value of x. We have taken this minus 3 to the next side, it becomes positive, x is equal to 3. And this is second 0, it will be denoted by beta. So the two zeros of the polynomial are 1 and 3 and they're denoted by alpha and beta. Now see here, after this we are coming in order to find out relationship between the two zeros and the coefficient of the equation. See here, general form of a quadratic polynomial px, it can be given by ax square plus bx plus c. But always remember that a should never be equal to 0. See here, why a should not be equal to 0? As it is a quadratic polynomial, if suppose that here a becomes 0, then if a becomes 0, it means the whole term ax square becomes 0. As 0 multiplied by x square, it will be 0. Then we are only left with bx plus c. Now it will not remain quadratic polynomial anymore. It becomes linear polynomial. Therefore only a will never be equal to 0 as it will change the degree of the polynomial. Now see here and assume that alpha and beta are its two zeros. If alpha and betas are two zeros of this given polynomial ax square plus bx plus c, then x minus alpha and x minus beta will be factors of this given polynomial ax square plus bx plus c. And then ax square plus bx plus c can be written as k within bracket x minus alpha and within bracket x minus beta. Here k is a constant. See here, the same way as we have written here, this polynomial 2x square minus 8x plus 6, it can be written in this way. 2 within bracket x minus 1, x minus 3, the same thing. In place of 2, we have written the constant k, x minus 1 root, our alpha, then again x minus another root, we have assumed it as beta. The same thing we have done here, nothing more. See, ax square plus bx plus c, it is a quadratic polynomial. In place of constant, we have taken k. As alpha is 1, 0, so one factor will be x minus alpha. Beta is another 0, so another factor is x minus beta. Now see here, we will open the bracket step by step. K, then this x is multiplied by this x, we are getting here x square. Then alpha is multiplied by x, we have got minus alpha x because here there is negative sign. Then this x is multiplied by minus beta, we have got minus beta here. Then again this minus alpha into minus beta, minus into minus, positive sign, alpha is get multiplied by beta, we are getting here alpha into beta. Now see here, k we have written, this is constant, then x square. In this minus alpha x and minus beta x, you can take minus as a common. So we have taken minus as a common. Inside the bracket there will be alpha plus beta and also x is common in both. So we have written x here. Now plus alpha beta. Now see here, we have opened the bracket and multiply all the three terms with k. Here we are getting, when we have multiplied it by k, kx square. Here minus k within bracket alpha plus beta x, and then again k is multiplied by this. Now we are getting here k alpha beta. Now see here, what we have to do is, we will equate the coefficients. Here with the x square, we are having a. And when we are comparing these two here, I have with the x square, the coefficient of x square is a, k. So we are comparing these two and we can say that a is equal to k. See here, on comparing these two, we are getting a is equal to k. Now again, we are going to compare coefficient of x. Coefficient of x is here b. Along with x, b is written here. Now we will compare this with coefficient of x here. Coefficient of x here is minus k alpha plus beta. Coefficient of x, whatever is written before x, it is minus k within bracket alpha plus beta. This will be equal to coefficient of x, that is b. This we have written here. B, it is equal to minus k alpha plus beta. Now see here, what we have done is, say this equation as first, here we have got value of k as a. This value of k as a, we have put in this equation. In place of k, we have written it here a from first. See, this value of k is equal to a, we are getting it from first. And now this a is getting multiplied by alpha plus beta within bracket. So we take this a to the next side and it will divide b. B divided by minus a, and here only alpha plus beta remains. Alpha plus beta, it means sum of the zeros. Alpha plus beta, sum of the zeros, it is equal to b minus a. Or this minus a, it can be also written as alpha plus beta, it is equal to minus b by a. So, sum of zeros, it is alpha plus beta, it is equal to minus b by a, where b is coefficient of x. It can be written as minus coefficient of, within bracket, coefficient of x upon coefficient of x square. Now see here, what we have done is, we have compared the constant term c. This is the constant term c, and after solving this polynomial, we are here getting the constant term as k multiplied by alpha and beta. These two, the c, here the constant term is c, and this c we have compared with k multiplied by alpha into beta. See here, c is equal to k into alpha into beta. Now see, from first equation, this equation, first one, we have got value of k as a. We have put this value of k here. Then we are getting c is equal to a alpha into beta. Now we are taking this a to the next side, as a is getting multiplied by alpha into beta. So when we are taking a to the next side, it will divide this c and it will be in denominator. Therefore, c by a, it is equal to alpha into beta. Or simply we can say that alpha beta, this is product of zeros. Product of zeros, it is equal to alpha into beta, and this is equal to c by a, where c is constant and a is coefficient of x square.